Hello everyone, my name's Adam. And in this problem, we're going to practice adding trigonometric expressions and then simplifying using our fundamental trig identities. So what we're going to start with is the expression 1 divided by 1 plus cosine x added with 1 divided by 1 minus cosine x. Now, looking at this, if you're new to these trig functions and expressions, it might look a little strange. But what we're going to start with is the same algebraic steps that we would do to add something like this. Say 1 over 1 plus y plus 1 over 1 minus y. So let's do a little bit of algebra review and see how we would add these two expressions and then see how we can apply it to our trigonometric expression over here. So how we're going to add these expressions is, remember, finding a least common denominator, which is the least common multiple of the two separate denominators, which in our case, 1 plus y and 1 minus y is just going to be the product of the two. And how we get there is by multiplying, say, our right-hand side by the denominator on the left, 1 plus y over 1 plus y, and multiplying the left-hand side by our denominator on the right, 1 minus y and 1 minus y. And what that's going to give us is the common denominator, 1 minus y times 1 plus y, in our terms 1 minus y times 1, or 1 minus y, plus 1 times 1 plus y, or 1 plus y. So let's see what this has to do with our trigonometric expression over here. Well, fundamentally treating like this is my y for cosine x, we're going to follow the same steps. To get a least common denominator, we're going to multiply our left and right-hand sides. Starting with the right, we'll multiply by our denominator, 1 plus cosine x over 1 plus cosine x. And on the left, we'll multiply by our denominator, 1 minus cosine x over 1 minus cosine x. And so what this is going to give us, again, is a common denominator of 1 minus cosine x times 1 plus cosine x. And the numerator is going to be the term 1 minus cosine x plus 1 plus cosine x. Okay, so we've added the expressions. Now we're going to see what we can do to simplify them. First, let's look at the numerator. We're adding two things, and there's no number in front other than 1 to distribute. So we can take this thing of adding the cosine and negative cosine. We'll cancel with each other, and our 1 plus positive 1 will give us 2. So the numerator will reduce to 2. Now in the denominator, two ways we can do this. We can FOIL all this out, but a good thing to remember that will be useful for us is some of our factoring formulas from algebra. So one of the formulas we have from algebra is if we have an expression a minus b times a plus b, that is equal to a difference of squares, a squared minus b squared. So treating our 1 and cosine like our a and our b, the bottom is going to multiply to 1 squared, right, which is 1, minus b squared, which is cosine squared. So now we have 2 divided by the expression 1 minus cosine squared. Now when we look at this, 1 minus cosine squared, this is going to come up a lot when you're doing these problems, when you have cosine squareds and 1 minus that, or even 1 minus sine squared. One of the fundamental identities that we're going to use is the Pythagorean identity. Namely, that sine squared x plus cosine squared x is equal to 1. Now again, what we have is 1 minus cosine squared x, and looking at our identity, we notice if we subtract cosine squared x from both sides, we get that sine squared x is equal to 1 minus cosine squared x. So we can make that substitution in our expression. So 2 over 1 minus cosine squared x is going to be equal to 2 divided by sine squared x. Now let's see what we can do to take this a little bit further. So 2 divided by sine squared x, well, let's write this as 2 times 1 over sine squared x. So this looks a little familiar to us in the fact that we know, at least, that cosecant x is 1 over sine x. Well, we have 1 over sine squared x. Well, how can we get there? Well, we notice if we just square both sides, that will give us cosecant squared x is equal to, squaring both top and bottom, 1 over sine squared x. So we can make that substitution. So 2 over 1 sine squared x, 2 times 1 divided by sine squared x is going to be 2 times cosecant squared x. And I'd say we're done simplifying that. So we added a trigonometric expression and simplified it with our fundamental trig identities to get 2 times cosecant squared x. Thank you very much.